Pandas has to search through data frame rows for matches when computing joins and merges, so it's useful to have different kinds of joins to mitigate costs. Let's explore joining more closely. To start, load the bronze and gold Olympic medal data again. The function merge does an inner join by default. That is, it extracts the rows that match in the joining columns from both data frames and it glues them together in the joined data frame. We can specify the keyword argument how equals inner, but this is in fact the default behavior for merge. Alternatively, using how equals left keeps all rows of the left data frame in the merged data frame. For rows in the left data frame with matches in the joining columns of the right data frame, the non-joining columns of the right data frame are appended to the left data frame. For rows in the left data frame with no matches in the joining columns of the right data frame, the non-joining columns are filled with null values. That's really quite a mouthful. As an example, when doing a left join with bronze on the left and gold on the right, the row for France is retained and a null value is inserted into the total gold column because gold has no France row. Conversely, using how equals right does a right join doing the same thing with the roles of left and right interchanged. Thus, here we retain all 5 rows from the gold data frame. This time, Italy has a NaN entry in the total bronze column because bronze has no Italy row. Finally, the union of all rows from the left and right data frames can be preserved with an outer join. With the argument how equals outer, we can clearly see that France was not in the top 5 gold medal winning countries and Italy was not in the top 5 bronze medal winning countries. To understand a bit better how joining works, let's examine the census data set again. We load 2 5-row data frames, population and unemployment, indexed by zip code. Remember, the only common row label is 2860. Pandas data frames have a join method built in. Calling population.joinUnemployment computes a left join using the index by default. Only the row 2860 is complete. The remaining rows are preserved from population with the unemployment and participants columns filled with NaNs. The row order also matches that of the left data frame in this case. The join method can also do a right join using how equals right. In this case, the 2860 row is preserved again, but the other rows are extracted from the right unemployment data frame with the 2010 census population values set to NaN. Notice the row ordering matches that in unemployment this time. The join method also supports inner and outer joins on the indexes. Here is the inner join returning a single row exactly as computed using pd.merge, and here is the corresponding outer join. As before, all rows have some null entries except one. Notice the outer join sorts the combined index. We've looked at a lot of equivalent Pandas tools for joining. Which one should you use? Occam's razor is a good principle here. Use the simplest tool that works. If you only need to stack 2 series or data frames vertically, the append method is sufficient. If you need more flexible stacking, or an inner or an outer join on the indexes, the concat function gets you further. The join method also joins on indexes, but gives more flexibility for left and right joins. Finally, the merge function is the power tool for joining when you need to join on several columns. That's a great deal of material to absorb. Try your hand now at joining in the exercises to make sure it all makes sense.